Unit 12 test review. Okay, on the first few problems, what we're going to do is we're just going to convert from one form to the next. So we could convert from radical to exponential, or we could go from exponential back to radical. So we'll be going between the two. All right, so I think most of y'all's teachers probably told you the whole, the crack in the bottom. So here you have your crack, and it goes on the bottom. So this would be your radical form, and then your exponential form would look something like this. So again, crack, bottom. Okay, so on this one here, I'm just converting it into exponential. So here I've got my 6. And then this is the number in the crack, so it goes on the bottom. So 6 to the power of 4/5. All right, on the next one, you've got x. The 4 is in the crack, so it goes on the bottom. Same thing again, you got your y. The 7's on the bottom, so y, and then 5 to the 7th. Again, same thing on the next one. Here you got a 3. And then 15 over 3, which actually reduces to 3 to the power of 5. You just do 15 divided by 3. All right, on the next one, I'm actually going to be changing into radical. So they look like this, and I'm going to go over here. So again, I've got my x. I'm going to do my radical. 8's on the bottom, so it goes in the crack, and then the 11. All right, again, 64. The 3's on the bottom, and then the 5. Same thing again. I've got an x. Q is in the on the bottom, so it goes in the crack, and then the p goes here. All right, next one. Now this one will be a little bit different. She knows that x does not have an exponent, but what it does have is it does have a 1, so it actually will go on the outside, and then the y will go on the inside. The 3 is on the bottom, so it goes in the crack. All right, on the next one, again, we're just simplifying. So on this one here, I'm actually going to keep it in exponential form. So they have the same bases, so I can actually add the exponents. I've got 36, and then I've got 2/5 plus 7/5, and that actually equals 9/5. So you just add the top. The denominators are already the same. And so my final answer is 36 to the power of 9 over 5. Okay, on the next one, I've got a 16. Now, I'm doing the square root, and I'm going to just see if 16 is a perfect square. And so it is. So I don't really have too much work to do here. So I'm going to do a 4. Now, this whole time there's been a 2 there for squared. So what I'm going to do here is I'm going to take all these x's and y's, and I'm going to make them in groups of 2. So I've got 3 x's. I've got 8 y's, and I've got 4 z's, and I'm going to do groups of 2. All right, so I've got one group of x, so 1 will go on the outside, and I'm going to kind of draw a line here because that's where all my exponents are going to go. And then see how I have that 1 left over, so it stays inside. Now I'm going to make groups of 2 out of these. 1, 2, 3, 4. I was able to make 4 groups of y, so y to the 4th. There aren't any left over, so no y's go in here. Same thing with the z's, 1, 2. I've got 2 groups, so this will be z squared. So the final answer will be 4x, y to the 4th, z squared, times the square root of x. All right, on the next one. Okay, again, I'm doing a square root. There's a 2 there, even though we never put it. I'm going to do the square root of 45 and see what kind of number I come out with. So the square root of 45 gives me that. Okay, that tells me I'm going to have to break that down. So I'm going to come over here, and I'm going to do 45. That's 9 times 5, and then 3 times 3. Okay, now, again, I'm going to do groups of 2. Well, here's one group of 2 of 3s. So that tells me I'm going to have a 3 on the outside, and then on the inside, I'm going to have what's left over, which is the 5. Okay, now I'm going to look at my variables. Again, I'm doing groups of 2. So I've got 6 x's, and I've got 7 y's. Okay, so I'm going to do my groups of 2. I've got 1, 2, 3. I have 3 groups of x. So x to the third. I'm going to make my groups of 2 out of my y's. I've got 3 groups, so y cubed. But then I do have 1 left over. So that stays on the inside. All right, the next one, I'm doing a cube root. So I'm going to check to see if 125 is a perfect cube. So I'm going to do math. Go down to number 4. I'm going to do 125. And it's perfect. So I don't have to do the tree like I did over here because the number came out perfect, where the other one came out as a decimal. So that told me I had to do that. Okay, so I'm going to do the 5. Okay, and then I'm going to do groups of 3. Now watch how I'm going to do this. I'm really just going to divide this. Okay, so 12 divided by 3 is 4. So I have x to the 4th. 15 divided by 3 is 5. So I have y to the 5th. And that's it. Okay, on the next one. Okay, this is where we actually start solving. So on these right here, the main thing really is you want to make sure you check them. And the reason you want to check them is make sure you get them correct. But then also you got to watch out for these extraneous solutions. Okay, so I'm going to be really focusing on the inverse here because I want to get rid of all these radicals. Okay, so the inverse of a square root is a square. So I'm going to square both sides. Whatever I do on one side, I got to do the other. Okay, so what I now have is I have x plus 12 equals x squared. Now, it's going to be a quadratic, so I have to make sure it equals 0. So I'm going to move all of this to the other side so that it equals 0. So now what I have is I have 0 equals x squared minus x minus 12. All right, now I can factor. So what two numbers multiply to get negative 12 and combine to get negative 1? That's going to be x minus 4 and x plus 3. Okay, so now I know that x equals 4 and x equals negative 3. All right, so now I'm going to check my work. I'm going to go to y equals. I'm going to type in the square root of x plus 12. And then in y2, I'm going to type in x. Okay, so I'm going to go to my table. Okay, the first answer we got was 4, and that's correct because these both equal 4. Okay. Now I'm going to go look at negative 3. And I know this would be my extraneous solution because this y1 and y2 are different. Okay, so this would be my extraneous. So this is the only answer, x equals 4. Okay, on this one we're doing a cube root. So, and again, I'm thinking about inverses. The inverse of a cube root is a cube, so I'm going to cube this side. Whatever I do on one side, I'm going to do to the other. So now I have 6 minus 2x equals negative 8, minus 6 minus 6, negative 2x equals negative 14, divided by negative 2, divided by negative 2, x equals 7. So again, I'm going to check it. So I'm going to go to y equals, and I'm going to do the cube root of 6 minus 2x, and then I'm going to come down here and do negative 2, and I'm going to check my table. All right, so we said x equals 7, so let's go down and look where 7 is. And there it is. And I know I'm right because both of those are correct. Okay, let's look at the next one. Now, this one both have squares, so I want to get rid of both of them. So I'm going to square both sides. All right, and once I square both sides, I have 8x plus 3 equals x plus 17. So it's just an equation with variables on both sides. I'm going to move the x over here. That gives me 7x plus 3 equals 17, minus 3, 7x equals 14, divide by 7, x equals 2. So again, you can always check your answer in the calculator, and I would highly suggest you always do that, because then you'll know right away if you're right or wrong. I know with my classes I was very obsessive about it, and hopefully they will all do it when they do their test. Because, again, you'll know if you're right or wrong before you do anything, before you even go to the next problem. All right, so we're going to go to our table. I said x was 2, so I'm going to go look at 2, and it's correct. These are both the same. All right, on the next one, here we are, again, getting rid of a square root, so I'm going to square it. So this gives me 2x plus 8 equals x squared. Again, I want to make it equal 0 because it is a quadratic. So I have x squared minus 2x minus 8. And again, I'm factoring. So what two numbers will multiply to get negative 8 and combine to get negative 2? So 4 and 2 And that would have to be the negative, and that would have to be the positive. So x equals 4, and x equals negative 2. All right, so again, I'm going to check with my calculator. Get out of that. Okay, so I've got the square root of 2x plus 8. Whoops. Okay. And then I've got an x. So I'm going to go to my table. We said x was 4. So 4 is a good answer because they both equal 4. Okay. And I'm going to go check negative 2. And that's not correct because those are different. So that's my extraneous. Okay, so I'm not going to check the rest of them using the calculator, but please make sure you do so. This will tell you if you're right or wrong, okay? All right, so in this one here, you have to get this radical by itself. So the first thing I have to do is I have to subtract 2. So that gives me x plus 10 equals x minus 2. Now, at this point, notice how this problem and this problem look the same. I'm not going to do this one. So on this one, it's the exact same steps. So pretty much from here, I would do the exact same steps that I'm going to do from here. Okay? So I'm going to get rid of the radicals. I'm going to square it. Again, that's exactly how you're going to start over here. Okay, so now I've got x plus 10 equals x minus 2 and x minus 2. Now again, that's x minus 2 times x minus 2. So you got to FOIL, or do the box. So here I'm going to have x squared minus 4x plus 4. Again, it's a quadratic, so I have to make sure it equals 0 to solve it. So I have x squared minus 5x minus 6, which gives me x minus 6 and x plus 1. So x equals 6, x equals negative 1. I think I will check this one just because I can tell there's maybe being extraneous. So just in case, I think I will check this one. Get out of the radical to put that plus 2. And then I'm going to leave my x. Okay, so I've got 6. So negative 1 I can tell right away that's not right because my y1 and y2. So that's my extraneous. So that's not an answer. And then the 6 is probably my answer, but again, it's always good to double check because you could have 2, and there it is. So that's my solution. Okay, on these down here, I'm not going to do 21 and 22. For y'all's level test, you just really need to focus on 19 and 20. So on the first one, again, you want to try to get the x by itself. That's how we've always solved equations. We've always tried to get the x by itself, always. Okay, so the first thing I would do is I would add 5. So that gives you x to the power of 2/3 equals 25. Now, to get rid of that rational exponent, I'm just going to flip it. So I'm going to do this side by 3 over 2. And again, like always, whatever I do on one side, I do to the other. So if I go to my calculator, I do 25 to the power of 3 divided by 2, I get 125. So x equals 125. All right, on the next one, again, trying to get the variable by itself. So if I were, let's say I just pretend and I get rid of things we're not familiar with. So let's say I just get rid of this 3 over 2. If I were to get rid of that 3 over 2, wouldn't the first step would be just to divide by 5? So it's the same thing, y'all. Nothing really changes except for this last little tidbit. All right, so you have x to the power of 3 over 2 equals 8. And again, I flip it. 2/3. Whatever I do on one side, I do to the other side. So if I do 8 to the power of 2/3, I get 4. So x equals 4. All right, that's it. I hope that helped you. If you have any questions, make sure you ask your teacher. Thank you.